Hello everyone. Um, Today our topic is active mass. Okay, the concept active mass of chapter chemical equilibrium. Our target is at least complete the 30 questions in each concept, so that will make help you in examination. And let's try to make different questions based on the topic. Yeah. Today our first question is active mass of 5.6 liters of N2 at STP conditions. Okay. The options are first option is 22.4. The second is 0.25 m. Third option 1 by 22.4 molarity. Fourth option is 4. Yeah. First, let's try to understand what the question is given. Here, the active mass of 5.6 liters of N2. Okay. Next, at STP. The condition is at STP. Yeah, and the answer here goes like. Firstly, any 1 mole of anything occupies 22.4 liters in gaseous state, right? But here given only 5.6 liters of N2. So if 1 mole occupies 22.4 liters, X moles can occupy 5.6. So 22.4 into X equals to 5.6, and the X will be like 1 by 4. So what we got now, the X equals to number of moles. Okay, and the concentration is like active mass is nothing but concentration, like C equals to N by number of moles by volume, right? So active mass equals to number of moles is 1 by 4 by, here the given volume is 5.6 liters. Okay, so 5.6 equals to 1 by 4 into 5.6, and here it goes like 1 by 22.4. So the option is third one. Well, our second question is active mass of 0.64 grams of SO2 in 10 liter vessel. Let's underline what's the information given. 0.64 grams and the 10 liters vessel. Well, let's try to find out the answer. As we know, the concentration equals to number of moles by volume. Um, Better to understand the active mass as the concentration term itself. Yeah, concentration equals to number of moles, right? What's given in the question is 0.4 grams of SO2 normal. The weight of the sulfur is 32 and the weight of oxygen equal to 16. So the weight of the SO2 equals to 64. But normally 64 grams of SO2 is equals to 1 mole. So x gram 0.46 grams equals to x moles, and the x equals to, so here we cross multiply. So 64 x equal to 0.64, x equal to 10 to the power of minus 2. So what we got is the number of moles equals to 10 to the power of minus 2. Yeah. So number of moles we got here, x value is the number of moles, and the 10 to the power of minus 2 by the volume is given in the question 10 liters, right? Yeah, by 10. So C equals to 10 to the power of, as the denominator goes to the numerator, the positive term goes to negative and negative goes to positive. So here is the positive term, so it goes to upper one, it goes to the negative. So the active mass equals 10 to the power of minus 3, and the answer is the second one. Well, our third question in this concept is, yeah, here the given question is 50 grams of CaCO3 calcium carbonate is allowed to dissociate in 22.4 liter vessel at 81 degrees Celsius. If 50% of CaCO3 is left at equilibrium, active mass of CaCO3, CaO and CO2 respectively. Well, whenever the question is like this, better we have to write the equation first. Okay, so the equation here goes like calcium carbonate solid dissociate like CaO plus CO2. The color is not perfect, let me change the color. Yeah, mention this whenever you are writing something about the equilibrium concept. Better to know the form, whether the solid state or the liquid or the gaseous. Okay. Yeah. Now, let's underline what is given in the question, so it makes us easier. Initially, 50 grams of CaCO3 is taken in 22.4 liter vessel. At equilibrium, 50% of CaCO3 is left. Okay. Initial, let's write like I. So I indicates the initial. Initially 0.5 grams. Normally the weight of the CaCO3 is 100 grams, but the given weight is 50 grams. So 0.5 moles is present at the initial stage, and 0 grams of this, 0 grams of this at equilibrium. So let's indicate with the E. E is equals to in equilibrium. At equilibrium, 50% of this, meanwhile 0.25 grams of CaCO3 is left. Meanwhile, sorry, 0.25 moles here, 0.25 moles left at equilibrium. So here it forms like 0.25 moles, and same like 0.25 moles. As X disappears here, X and X are formed here. Well, meanwhile here the 2.5 is disappears, so 2.5 and 2.5 forms. Okay. So as I said, they are asking active mass. So active mass equals to concentration term N by V. But one thing, the active mass for solid and liquid are unit unity, I think. Meanwhile we have to take it as 1. Okay. So active mass, whenever come to its here, it's solid form, so the active mass of this is 1. And same here, so it's 1. But we can, it says a gas form, so we can find the active mass. So 0.25 can be written as 1 by 4, and the down is the volume, so volume is given in the question is 22.4. So the answer goes like, they are asking respectively, right? So initially CaCO3 is 1, and CaO is 1, and next for the CO2 is 1 by 4 in 22.4 is by like 1 by 86, sorry, 89.6. So the option is second one. Well, here on is question, it's a statement wide. Okay. They're asking the following are statements about the active masses. So next, the correct combination is okay. Active mass of pure solids and liquids are taken as unity. As I said in the previous question, yes, the active mass of the solids and the liquids are taken as unity, so it's a correct one. Next, active mass of electrolyte is taken as molality. Hold on, electrolyte is like yeah, it's like electrolyte is something like in a liquid form, electrons and something like. So molality is taken for kg, right? Solvent